Now we will see some illustrations based on principle of conservation of energy as well as work energy theorem. Remember very well, work energy theorem can be applied in every situation, but principle of conservation of energy can be applied strictly only in conservative force field. That too, when external forces do not do any work or when external forces remains absent. Now let us look at some problems on principle of conservation of energy. As shown in figure, there is a block of mass m which slides on the smooth track. As shown in figure, the initial height of the block is 1 meter and the final height of the block is 0.5 meter. During its travel of 5 meter in horizontal direction, calculate the velocity of the particle at the instant when its height is 0.5 meter. As we know that the gravitational force field is a conservative force field, so mechanical energy of the system will remain conserved. What is mechanical energy? Summation of kinetic energy and potential energy is the mechanical energy. Initial mechanical energy equal to final mechanical energy. So kinetic plus potential at initial position equal to kinetic plus potential at final position. Kinetic energy at initial position is 0 and potential energy at initial position is mg into 1. Kinetic energy at final position is half mv square and potential energy at final position is mg into 0.5. So loss in potential energy equal to mg 1 minus 0.5, this will be equal to gain in kinetic energy. So mg into 1 minus 0.5 equal to half mv square. That will give us v equal to 3.13 meter per second, which is the velocity at height 0.5 meter. Now let us look at one more illustration. Suppose a body moves from a point A to point B under the action of a force varying in magnitude as shown in figure. In the force displacement graph, find the work done by the force during its displacement. During the displacement of a body by 7 meter, since from 0 meter to 5 meter force is varying and after 5 meter force is constant. What is work done? Work done always remains equal to area under force displacement curve. So work done during displacement of 7 meter equal to half into 5 into 10 plus 2 into 10. That is equal to 45 joule. Let us see one more illustration on principle of conservation of energy. A small block of mass 100 gram is pressed against a horizontal spring fixed at one end to compress the spring through 5 cm. The spring constant is 100 Newton upon meter. When released, the block moves horizontally till it leaves the spring. Where will it hit the ground? 2 meters below the spring. Since the spring force is conservative force, initially spring is compressed by 5 cm, so elastic potential energy remains stored in the spring. When system is released, whatever energy is stored in the spring, same energy is transferred to the block. Let us assume that the mass of the block is m, which is 100 gram, so half kx square equal to half mv square. So we get value of v. Now since the block is to shift by a vertical distance of 2 meter, initial vertical velocity 0, we can apply S equal to ut plus half at square in vertical downward direction. We can write 2 equal to half gt square. So we can find the time. And what is x? X equal to vt. What is v? V can be already found by the above equation. Half into 100 into 0, half into 100 into 10 to the power minus 3, v square equal to half into 100 into 5 into 10 to the power minus 2 square. So x equal to vt equal to 1 meter from the free end of the spring. Let us look at one more illustration based on principle of conservation of mechanism. As shown in figure, a block of mass 1 kg is placed at the point A on a rough track as shown in figure. If slightly pushed towards right, it stops at the point B of the track. Calculate the work done by the frictional force on the block during its transit from point A to point B. Once again, listen to the problem. As shown in figure, the block A is moving on a rough surface from point A to point B. The initial velocity at point A is 0 and the initial position of point A is 1 meter above ground and final position of point B above ground is 0.8 meter. You have to calculate the work done by frictional force during the transit of block from point A to point B where block gets stopped. Since in this problem block is losing the potential energy, remember in this problem we cannot apply principle of conservation mechanism because frictional forces are non-conservative forces. Here we can apply work energy theorem. What is that? Loss in potential energy equal to what? Work done by friction. Because kinetic energy of the block at B is 0. What is loss in potential energy? That is equal to mg 1 minus 0.8. That is equal to 1 into 10 into 0.2. This is loss in potential energy. So work done by friction in this case equal to minus 2 joule. Why minus? Because frictional force acts in opposite direction to the displacement.